let's go. Okay. X and Y switch. Why? It's an inverse. Talked about that yesterday. Inverses can be written as an inverse function, which is kind of awkward and weird because we'll just leave it there. We talked about how they failed the horizontal line test, so if you switch them, they would fail the vertical line test, which is why the domains need to be restricted of original functions. So what comes out of inverse functions will only be within these quadrants. That's important to know. And then I said, hey, you should study your unit circle just a little bit, but let's go have, some fun. Do you guys already have tangent inverse in your forever card number 1? Didn't we put that on the tangent graph? We wrote tangent inverse also? Good. This was from last year where they needed to add it, and you guys already did because I remembered it. So all this to say there are graphs of all the inverse trig, but the most important one is tangent inverse because the AP in CalcBC loves to randomly bring up some sort of limits to infinity or negative infinity of tangent inverse where the only way that you will know it is if you visualize the graph. So, quick heads up. Moving on. Now let's have some fun. Remember derivatives of inverses? Oh, it was a thing that some of you never quite mastered. Well, that's okay. That's what BC's for. Kind of. Really? In my mind, BC is for mastering Calc 1 material and being introduced to Calc 2 material. Now, does that mean that some of you won't master Calc 2 material? No, I think some of you will. But I would say at the end of BC, you have a mastery of Calc AB material. Very different than last year. And I would say you have an introduction to Calc 2. Anyway, all that to say, we're going to work on the derivative of inverses. Just a little bit further. So I'm not super confident on your mastery of this topic. I think for good reason. What's the notation say? F inverse prime of A equals 1 over F prime of B. And another way of saying that is the derivative of the inverse at an x of the inverse is equal to 1 over F prime of F inverse of A. So is the A in the answer? Kind of. The A is not at all what's being plugged into F prime, but is the A involved? Yeah. The A is the x value of the inverse that gets me the y value of the inverse, aka x value of the original to plug in. Whew, and that's where we get lost. We talked about last year why this is true. I don't think we're going really into depth as to why. We could write it implicitly and we can derive it. We'll talk why as far as inverse trig, not why in terms of like the general formula. But what I want to see is if you guys can apply it to the example down below. So once you get there, ready, set, okay. So, example. They're trying to up our security, and I think in doing so, at times they leave loopholes for a bit, and then they're trying to, I don't know what's going on. There was some security breach on North Campus earlier this year, and so they're trying to make South Campus secure, and in doing so, there's some weird things happening. But you guys going? That could be one way. Some of you guys are remembering from Riley's question, oh wait, there were 2 ways of doing this last year. One way is using this straight out formula, and the other way was switching x and y and deriving implicitly. I'm not sure which way you chose. Sadly, at the end of the day, you do have to know this formula because, as you guys saw at some points last year, whether or not you remember it, AP questions are sometimes tailored to forcing you to use this formula. If they don't give you a function, you can't switch x and y and derive implicitly. You're going to have to use what they've given you. But in this one, you technically can choose. You technically can choose. Okay, I'm not giving you guys tons and tons of time. Let me go through really quickly the two different ways of solving. Sound good? So one way, I'm keeping my remote close just in case something else unexpected comes up. Oh, dear goodness me. Here we go. Let's use the formula this way. So the formula would say f inverse prime of 1/2 is equal to 1 over f prime of f inverse of 1/2, which would equal 1 over cosine of f inverse of 1/2. Wouldn't that be the same thing as sine inverse, since I can take the inverse of this, of 1/2? Because I could actually find the inverse function of this one. We can't always. And sine inverse of 1/2, Justin, why'd you say pi over 6?
Because it's restricted to pi over 2 to negative pi over 2, and so it equals 1/2 pi over 6.
Sine won't be positive in the fourth quadrant at all. Forget that. In the first quadrant, y is going to be up a little at. Got it. So pi over 6 is what needs to be plugged into cosine, which is what we know. We know angles need to go into trig function. Values need to get plugged into inverse trig functions. So 1/2 goes into sine inverse. That pops out the angle of pi over 6. We can plug that into cosine. And that leads us to, because I'm running out of room, we'll go that way. Well, isn't that just 1 over root 3 over 2, which is 2 over root 3? Or 2 root 3 over 3. But the other way, I'm going to do green for review. The other way could have been, let's switch x and y. Let's take d dx of the whole thing. 1 equals cosine of y, of y, times y prime. dy dx is equal to 1 over cosine of y, such that, we need a y. We were given an x of the inverse. So we could off to the side plug in negative 1/2 is equal to sine of who? Did I totally miss the negative 1/2? Oh, I'm dumb. I didn't put a negative, did I? Okay, so hold on. If we put a negative, Justin was right according to what I gave, but it's not going to be positive pi over 6. It's going to be, because I do need that fourth quadrant. Did you guys see that and not tell me? Goofs. You took that. So then instead of positive reciprocal, it'll be negative reciprocal, right? Because y is going to equal negative pi over 6. Does it end up being the same thing? Yeah. Both ways work, as long as you're given a function. If you're given AP clues, you're stuck with the formula. Maggie. The formula way. 1 over f prime of f inverse of a. That's the struggle, because you can't actually manipulate the x and the y and solve for the values and plug in. Implicit's impossible. Well, hold on though. Couldn't you find the formula yourself though, if that's what you like? Couldn't you? You could do that. You could do d dx of both sides. You could actually find the formula every time if you wanted to. I just don't know if that's really that much easier. Yeah. Sorry, Justin, go ahead.
Isn't cosine 11 pi over 6 positive? Like, I don't understand why there's a negative and there's negative 2.
Oh, because I was going fast and not even thinking about what I was doing. Thank you. What Justin just catch me on? He was like, wait, you're wrong. Why was I wrong? All students take calculus. The positive x is still a positive x even though it's negative pi over 6. Struggle. I was right, but I was right the wrong way. Ugh. I was right, but I was right the wrong way. Negative pi over 6 is the angle, but both of them have a positive root 3 over 2. The sign is... I just did it again. The sign is what changes signs. Thanks, bud. I was wrong. Flip the sign. I was wrong. Keep it. Okay. Good. Yeah, me too. Yeah, I did the same thing. Yeah. Fourth quadrant, cosine's positive. What is going on? Do you have to write all these words? No, but I do want you to write the important information. What function are we going to be discovering, exploring with? Okay, f of x, x to the 5th plus 2x minus 1. Get it down. We have the point 1, 2 on f. We have the point 2, 1 on f inverse because x's and y's switch, right? We're trying to think about it geometrically, and that's important because I said we're going to triangles, and triangles are a geometric approach to the derivatives of the inverse trig. So the function, x to the 5th plus 2x minus 1. 1, 2 is on the original graph, so 2, 1 is on the inverse graph. They're asking us for the derivative of the inverse of... Oh, that's weird notation, right? The derivative of the inverse with respect to x at 2. Okay, a little bit new notation. Means the exact same thing as... Same thing, right, guys? Just notation that I've never used with you guys before. So good to see. And I want you guys to go ahead and group up in your pairs, and hopefully at least one graphing calculator for the both of you. If not, let me know. And I want you to do 1, 2, 3, 4, 5, 6, 7, 8. Yes, please. Well, unless you want to graph x to the 5th plus, that'd be kind of gross. Pause. Could you actually find the inverse function for this one? No, if you switch x and y and solve for y, it's impossible for you guys by hand, well, even at all, to solve. Do any groups not have a calculator? Oh. Hold on, let me see if this one has battery. Oh yeah, that works. Do you want to use Maggie's? Anybody else not have a calculator? You're an Aryan's group though, right? One per group. Do you guys have a calculator? There you go. They need one. You guys have one. You guys have one. You guys have one. Good. Do you guys remember what the word one-to-one is? Passing the horizontal. Function, vertical. One-to-one function, horizontal. Invertible or one-to-one is a function whose inverse is a function. Oh, it's in my pocket. I don't think you'd be able to, but you could sketch it on your notes. Because you just... Guys, how do you reflect an inverse? It's across... Oh, they already tell you. Draw the y equals x line and then flip it piece by piece. That's what I would do. You can draw the y equals x line. Major brownie points if you can figure out how it is possible to do in your calculator in parametric mode. Ooh. Just saying. Talking about brownies at a time like this, that's just not fair. No. Oh, this is hilarious. Not because I'm talented in any way, shape, or form, but because we're going to learn from others. Other teachers that are way too busy, that'll hopefully help. Ooh, that'll be good. I like that idea. I love harmony, so in some ways, I mean, I was an alto, but still. Back in the day.
I'll do the triangle. I'll keep rhythm. I think it might, like, I'm not gonna say. Love that. I just got a really high pitched voice, and so I was on like worship team, I was on a choir, I was all those dudes, and then just puberty. I just like grabbed the light with that sign and I snitched.
But look, I got it on my calculator. Dun 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 dun. Dun. How'd I get it? How'd I get it? I cheated. X equals y to the 5th plus 2y minus 1. I cheated in parametric mode. It's a thing. That's pretty cool. You can switch x and y in parametric mode as long as y becomes the t and then x is the other equation. Just careful. Parametric mode, t, min and max, you would have to go negative and positive to show the whole graph. Otherwise, it'll be kind of confused. But look, there's the inverse.
Wait, so how do you do it without using parametric?
You can't. Well, unless you switch x and y and solve for, but in this one you can't. Sadly, there's no x equals in function mode. Where are we at? Sketching the graph of the tangent? A tangent line for the summer, from the summer review packet or summer packet for CalcAB. A tangent line is a pencil against a graph at a point. Show me, or show the metric. Make y equal to t, because y is your variable. And make x equal this equation in terms of t. With, oh, I think I did like negative 4 pi to 4 pi. Is that right? How would you reflect this line across the... Hey. Naomi, it's a present.
They changed it? Are you kidding me? I finally went and called it out.
Do you guys need me to zoom in on page 1? Sorry, I'm having fun over here. Lo siento. There you go. It's an old version. I think it's King James. The ESV says, "For me to live is Christ, to die is gain." But I think King James is for to me. For to me to live. So to me, to Paul, right? So for to me or for me, for to me, for me, it's like him referring to himself. To me, this seems like. So to me, to live, the act of living, to live is Christ, period. And to die is gain. So that's what the to me is for. Because that's the passage where he's saying, like, if I'm present or if I'm absent in the body, he's like, if I'm present with you, it's a blessing because I'm going to keep on working for the Lord. But if I die, it's also a blessing because I get to go be with Jesus and forget all this stuff. So he's saying, like, you can't hurt me because I don't care either way in a sense of whatever God has for me, I'm good. Yeah. Which is why when he's in shackles and bounds, is it 2 Timothy where he's in prison? And it's like his last letter to Timothy. And he's like, I'm as free as I'll ever be when he's chained to guards. We know that from church, but yeah. It's good stuff. It's good stuff.
After I get the derivative,
I think that's right. Yeah.
Put it in the denominator when I'm looking for this value. How do I get it? Do I just plug in 2?
You have to plug in the x they give you.
Okay.
And then this is one of those last year where it's like guess and check, and it's going to be a nice number. But in theirs, they gave me the point 1, 2 becomes 2, 1. So I'm going to use that fact. They said find it 2, 1, right? Find it x equals 2.
Yeah, for 8.
Yeah, so we're able just to plug in the 1.
For this point?
Mm-hmm.
Oh, so basically...
Because it'd be 5y to the 4th plus 2, so I need to use the y value.
Okay, so you, like, basically, since you're plugging it into the inverse, you just switch those two? Okay.
Actress, but yes. So it's okay. Acting can pay the bills. But it's a fun side hobby. You can totally like have that personality. It just puts people at ease when they have to go in and go under your knife. That's rough. Anyway, where are you guys at? You stopped at 3? So we sketched that guy. Did you guys even figure out what was going on when they said, how can the derivative help you know that this is invertible? Because this is our f of x. It is 1-to-1 because if you looked at it, it does pass the horizontal line test. But it's like, doesn't this also tell you it's 1-to-1? How? How does this tell you it's 1-to-1? No? Well, okay, yeah. The function, the derivative does pass the vertical line test. The derivative is a function, so that does say the original is 1-to-1. But you know what else I thought of? I also thought of the fact that the derivative never went negative. What does that mean? The original function never changes direction. If it never changes direction, could it fail the horizontal line test? So 2 ways of thinking about it. Yes, the derivative is an inverse. Sorry, that's not 1-to-1. My bad. You convinced me that I was right. The derivative is not does not have anything to do with one-to-one in the sense of the definition. For a function to be one-to-one, for a function to be an invertible, its inverse is a function. So this guy passing vertical line test, that proves one-to-one. The derivative doesn't technically have to pass the vertical line test for that to be true. But the fact the derivative never goes negative, this function never changes direction, whatever it's doing, it won't fail the horizontal line test. Anyway, all that to bring us to numbers, what is it, like 3, 4, 5? Graph the inverse. I showed you guys parametric mode, how you could have done that. I graphed the original by making, if you guys want to see my calculator, by making x the variable this time. I made x the variable, so y equals x to the 5th plus 2x minus 1. This one, y was the variable, y to the 5th plus 2y minus 1. So I got both of my functions. I just eyeballed it and sketched a line at 2, 1 for the inverse. I reflected it across the line y equals x. And as I did, this doesn't hit the original function at 2, 1. It hits the original function at 1, 2. And why does that make sense? The slopes are corresponding. I'm not saying congruent or equal. The slopes won't be the same because those are two very different lines, but they correspond or they are related to each other at points where the xy is the yx of the other, right? Does that make sense? So the x's and y's switch. So the point 2, 1 on the inverse graph relates to the point 1, 2 on the original graph, but here's the dealio. Are the slopes the same? And the answer is no. How are the slopes related? Where are we up to now? Sketch the tangent line of the 2, 1, reflect the line across. It hits at 1, 2. What is the slope of the reflection of L? What is the slope of L? How do I know the slope of the reflection of L? Isn't the slope of the tangent line just the derivative? Didn't we already find the derivative? So couldn't I just say this is f prime of, what was the point that we just said it hit? 1, 2. So couldn't we just plug in 1? And wouldn't that be 5 times to the 4th plus 2 times? So plugging in 1, don't I get 7? Right? What would the slope of L be? Nope. That's the slope to the original curve. That was going like this. This guy was going like this. Oh, what's the relationship between the two? Check out your group. Is one positive and one negative? It's just 1/7. It's not truly perpendicular. If we were to get a protractor out, it does seem like it would be. The protractor. Our guess, ooh, wrong way. Our guess is going to be 1/7 without us using graph paper and making it super precise, which maybe we should have done. So then our guess for the inverse derivative at 2 is, how do we check it? The formula that we just did on the page before. So how would we take the derivative of the inverse function at x equals 2? 1 over f prime of f inverse. Hold on, what am I plugging in? If I want the derivative of the inverse at 2, what's going into the f prime? The most common mistake. It's 1 over f prime of f inverse. It's 1. F inverse is a y value of the inverse. The x of the original is going to be the y of the inverse. So is it 1/7? And the answer is, why, yes, indeed it is. Not negative, because if you guys looked at them, one doesn't go negative, whereas the other one's positive. So geometrically, I just had you deal with the whole idea of reflections of inverses. And if you were to draw this super precisely, like actually having these nice sketches and actually taking and skimming at 2, 1, and then bouncing off, or not bouncing off, reflecting over y equals x, you would notice that both slopes are positive, which means they can't be perpendicular to each other. If they're both positive, one's not the opposite reciprocal of the other. One skimming at 2, 1 makes the other one skim at 1, 2. So in order to relate this guy to 1 over the slope of the other guy, I can't plug in 2. That's a point of the inverse. I need to plug in 1 because that's the corresponding point of the original. That might help a few of you that are super, super visual. For some of you, you're like, just give me a formula, I'll figure it out. But it does give you a reason geometrically as to why the slopes are related the way they are, and as to why we don't plug in the x of the inverse to the original. The original corresponding point has been flipped. So I need the x of the original, which is the y of the inverse. Speaking of geometry, triangles. Speaking of geometry, triangles. If we are given y equals sine inverse of x, can't I say it's the same thing as x equals sine of y? Think of it this way. If I were to take sine of both sides, or you can think of switching x and y and ending up at the inverse of the inverse, which is the original. Ooh. But the easier way is probably just taking sine of both sides. Now, if I was to derive this using implicit differentiation, which you guys have been practicing, some of you already, we would get 1 equals cosine of y, which we talked about on the page before. But here's my question. If the derivative of inverse trig is just another trig function, why on earth in our forever cards, when we get to these formulas, are there no trig present in any of their derivatives? We just took the implicit derivative, and there's trig right there. But why in all of our formulas on our forever cards is there no trig for any derivative of an inverse trig? Derivative of sine inverse. What's the derivative of sine inverse? 1 over the square root of u squared. But cosine. Yes, it is. This is cosine of y, not cosine of x. And guess who y is? An angle. An angle of what? A right triangle. That's where trig comes from, isn't it? Guess what x is? A ratio. What ratio? Well, it's sine, isn't it? Isn't that opposite over hypotenuse? So I can label x as the adjacent? No, opposite over hypotenuse. X as the opposite, 1 as the hypotenuse. How am I going to be able to quickly plug in 1 minus x squared as the adjacent when it wasn't given to me anywhere else in the problem? Pythagorean theorem. C squared minus b squared is a squared. Square rooted is a. Why did I do all this work? Aren't we supposed to be plugging in cosine? Who's cosine? Look at your triangle. Isn't cosine just adjacent over hypotenuse of the triangle, which is 1 over the square root of 1 minus x squared? Dun, 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 dun. All of the inverse trig derivatives come back to a triangle. A triangle that was formed from the inverse relation. Inverse relation where I have y being an angle, some sort of ratio I fill in, Pythagorean theorem to find the third side, and you wouldn't have to memorize any of those formulas ever again. But what happens if you have something more exciting? Like, what? I don't know why I'm doing that. Oh. I'm saying, is there another way of solving this? Yes. Couldn't I just find the derivative of sine inverse of x such that x equals 1/2? And couldn't that be 1 over the square root of 1 minus x squared such that? So couldn't I have plugged in? Then couldn't I have simplified? Then couldn't I have gotten 4 over 4 minus 1 over 4 is 3 over 4? Then couldn't I have square root of 4 is 2 and it pops up? for sine inverse. So we could have done that another way. But what happens if we have a chain rule? Does the triangle still work? This is where it gets interesting. What happens if we have a chain rule? What happens if we have a chain rule? Does it still work? How would you guys say that I should start off this problem? Kind of, but it gets more complicated with chain rule. To be safe, I would keep it legal, and to keep it legal, what would I tell you to do to both sides? It's going to be better that way. Because doesn't this now show I have 2x is equal to tangent of y? Whoa. No, I got it right. It's a little more complicated than just switching x and y. That's the inverse relation. So how does that translate to my triangle? Who's my angle still? What does 2x over 1 give me? What ratio does it give me? Which sides? Opposite over adjacent, SOHCAHTOA? Okay, so then plug it in. I don't know what color I'm using or why. Can't I make 2x my opposite and 1 my adjacent? What's my hypotenuse using Pythagorean theorem? 1 squared plus 2x squared, right? Wait, if I was to take the derivative, of 2x tangent of y, wouldn't I get 2 equals secant squared of y times dy dx? Then wouldn't dy dx equal 2 over secant squared of y? Who's secant? Pause. 1 over cosine. What's 1 over cosine? Hypotenuse over adjacent. And what's hypotenuse over adjacent? Check it with a formula and you'll see I'm right. Bye, cool kids. I'll see you later. Isn't it u prime over 1 plus u squared? We have to review the derivatives of inverse trig. Do you have to use triangles for every problem tonight? No, you can use the formulas, but do you need to re-memorize them, some of you? Yes. So there are all the formulas that you can just plug and chug into, but they all come from triangles. Bye, guys. Later, gators. Yeah, you go grab it.
Can I go to the library? Because I never got the purple.